Welcome back, folks. Let's try and solve some of the math problems on the hypothesis test. So let's look into the very first question. What we are given, we are given the mean is equal to 350, and the claim is that mean is not equal to 350. The level of significance is given to me 0.05, sample size is given to me 80, and z value is given to me sigma known. So again, if you are confused about whether to use the z distribution and t distribution, I will highly encourage you to watch the video from chapter number 9 where I talked about the difference between z distribution and t distribution, when to use which one. Okay, now what we need to find the critical values and the critical region and the proposed hypothesis test. uh, Determine whether or not to reject the null hypothesis based on the test, and also state the possible decision error type. Okay, now when we have this question in front of us, it is not equal to. So if I draw the normal distribution graph, not equal to will be a two-tail approach. So, and it is also given to us that the level of significance is 0.05. So what we're going to do is we will divide this 0.05 over the two tails. Or if this proportion creates a problem for you, you can convert it into percentage also. So this 5%, I'm going to divide it over two sections. So half's going to go in this region, half's going to go for this region. So this is 2.5% of the region. This is another 2.5% of the region, and this region is also called as critical region. This again, this is also critical region. Both of the ones which I've colored with the pink are called critical region. And now the z value which you're going to find correspond to these is called critical value. So these ones will be critical values. All right, now I'm gonna try and redraw it and try to simplify this question. Okay, so this and this value, and I wanted to find these two values when the level of significance given to me as 5% or 0.05. So probability value at this point, again, listen me carefully. I'm saying the probability value at this point will be 0.025. Why this is 0.025? Because probability value starts from here and from the 0 and goes up to this point, which is 1. Okay, and the values always move from the left hand side towards the right hand side. We are dealing with alpha of 0.5, means 5% the level of significance, which has to be divided into two sections. Half of that is 0.025, another half is also 0.025. 0.025. This half I've divided over this section, so the probability starting from here up to this point, up to, let me change the color please. So up to this point is 0.025. Now the middle section, this is the confidence interval section, which if alpha is 5%, this will be 95%. Confidence interval of 95% or 0.95. So if you add 0.025 plus 0.95, this point will become 0.975. So again, I have in detail told you how you're going to figure out the values. For those students who directly like to jump into the chapter number 10 without studying chapter 7, 8, for them I've tried to give you the as much explanation as I could. But if you're still struggling, please, I'll highly recommend you to watch the previous videos. Okay, all right, now the value uh, here is 0.025, as I said, correspond to this value, probability value. I will try and find the z-score. Z-score here will come out to be negative 1.96, and on the right hand side correspond to this point, this z value will be positive 1.96. Okay, and these values are critical values also. Now what we're gonna do is we're gonna see where the test statistic value lies. So z test is equal to negative 1.68. Now this negative 1.68 lies where on this graph? So again, if you forgot, the z value right in the middle is equal to z value here is 0. So negative 1.68. This value will lie somewhere here, but it will lie on the right hand side of the critical value. So this is the critical value. Let me just change the color. Hey, this is the critical value. It will be on the right hand side of the critical value. So somewhere here, negative 1.68 will lie. Okay, so now where does it lie? It lies in the confidence interval region. If the z test value lies in confidence interval region, then you cannot reject null hypothesis. So if you cannot reject the null hypothesis, it means whatever the premise is, that mean is equal to 350, we will take it, we will accept it. So mean is equal to 350. If the z value would have lied in the critical region, in this region, then we would have rejected the null hypothesis and accepted the alternate hypothesis in that scenario. So we would have said that mean is not equal to 350, mean is something other than, mean is not equal to 350, but it is something other than 350. Okay, we don't know what it is, but it is something other than 350. We can hence we proved. Okay, that's what we would have said. Now, so we've covered this part also. So this part is covered. State whether or not to reject the null hypothesis. So in this case, we cannot reject the null hypothesis. State the possible decision error type. Now there are two types of error which can exist: type 1 and type 2. So I always recommend my students to remember one, and if the opposite thing happens, then you can always say the other error. So in this way you can always remember it for a longer term, because what I've seen for my past experience, if I try to remember both of them, then I confuse myself in both of them. So type 1 error is if you reject null hypothesis HO, then that is a type 1 error. If you cannot reject the null hypothesis, can't reject null hypothesis, then it's a type 2 error. Okay, so hopefully you were able to understand how to approach these kind of questions. Now I'm gonna try and do one more question with you guys about the hypothesis testing. Okay, so let's look into the question number 13. We're gonna do this one. Okay, so we are given the mean value is 45.2 and mean value is greater than 45.2. I will recommend you guys to pause the video and at least try and label the diagram for this question. Okay, now welcome back, guys. So this is what mean value is equal to 45.2, mean value is greater than 45.2. so greater than means it is a right tail. Mean value equal to 45.2, mean value is greater than 45.2, right tail. Now level of significance, let's see how much is given to us. level of significance is 10%. 0.10 is 10%. Sample size is 12, and test value is this much. Sigma known, because sigma is known, that's why I'm using the z distribution. On top of that, it is normally distributed too. So let's do this question. Okay, so z-test, let me write down here, z-test is equal to 1.45, and yeah, that's pretty much it. What we need, alpha value is 0.10. If alpha is this and it is a right tail, then here the value will be 0.9 for the probability, and correspond to this I will try and find out the z value. So I'm gonna pause the video for a second and try and find out the z value correspond to this one. So this should be, okay, 1.28. That's the value, 1.28. Because this is on the right hand side, so this value is positive. Now z-test value is 1.45. This value will lie on the right hand side. Obviously I can see, because the z value right in the middle is equal to 0. So this value is on the right hand side, which is the critical region. Also the value lies in critical region, so I will reject the null hypothesis. Reject null hypothesis. So if I rejected the null hypothesis, then what kind of an error is this? This is type 1 error. Type 1 error. Okay, so hopefully you were able to understand how to solve questions like this. Now I'm going to take a question on the t distribution also. So let's do this question. Okay, and let me just make some space here by erasing, so that I don't need to move the screen again and again. And so hopefully you are following along and enjoying this topic, and hopefully you're having a good day too. And yeah, if you want to like the video, you can like it, and subscribe it, you can subscribe it, but that's not mandatory. Just I'm erasing something, so I just kept on don't want you guys to get bored. I was just talking. Anyhow, let's look into this question number 15. The mean value is given to us. Mean value is less than 4200. Level of significance is given to me. Sample size is less than 30, which is 18. T value is given to me. So if I were to draw it on the distribution, it will be a left tail. I can clearly see it is a left tail. Now here I have to find the t value. And whenever you are finding the t value, you don't worry about the probabilities here like we did it in the previous question. Only thing we look for is degree of freedom and alpha value. So degree of freedom will be n-1, n-1, which will be equal to 17. And alpha value in this question is given to me 0.01, and 0.01 under one tail. This is one tail, not two tails. So when I'm going to go to the t distribution table, and I will look for one tail 0.01. Okay, this much under one tail. So for 17 and one tail 0.01, that will come across as 2.567. Now here, because this is a left tail question and the t-value is a negative also, I will place a negative. The table itself doesn't give you a negative or a positive value like the z table, so please make sure you keep this thing in the mind. All right, and now we are given test value. This test value will lie where? This test value will obviously on the right hand side of the critical value. This is critical, oops, critical, this value, and this is test value, t test value, which is equal to 2.2.396. This is on the right hand side of the green value, and this region is confidence interval region. So if this is confidence interval region, I cannot reject the null hypothesis. Cannot reject, I'm saying. So I'll keep the null hypothesis. So if I cannot reject the null hypothesis, you can decide what kind of an error is this. It will be a type 2. Type 2. If I cannot reject the null hypothesis, you reject it, it's a type 1. All right, so hopefully you were able to understand this question. I will see you with another video. Till then, goodbye.